Our products should be affordable, they should be super energy efficient, they should be easy to install, and ideally they should also be very small so they can fit in all types of housing scenarios. And if we're talking about housing scenarios for residential air conditioning, of course we have apartments. Apartments have the smallest living space available. That means the requirements towards installation are actually very high. Also here we're looking for the most affordable solutions. And townhouses offer more living space, but due to the proximity to the neighbors, there's still some restrictions, especially when it comes to noise. And finally, detached houses on the other end, they have more living space available. The installation limitation is low, and here we have usually more budget available. So I want to run you through these different housing scenarios and show what we can do there to have a more green and sustainable lifestyle. Let's start by looking at apartments. Of course, we have cooling demand, heating demand, domestic hot water demand. So the types of units that you could find here from our end are, for example, our heat pump water heater and our split systems, right? So let's start by looking at the split systems first. So when we thought about what we can do better for apartments, the first idea was, of course, to make the units more compact. And this could only be achieved by looking at the hardware. To be more precise, by improving the wind wheel and the grill. This way we could increase the airflow efficiency by 12% and the air volume by 10%. But in these days and age, looking at the hardware is not enough. We also have to look at the software side of things. That's why we have a very strict simulation regime in place. Before each physical lab test, there will be at least 300 simulation cycles. So that means until the unit is finally ready, it will have undergone several thousand of cycles of simulation. And only then the best configuration when it comes to efficiency, performance, and noise is selected. So by applying all these technologies, we really could go down and have a more compact design for our latest generation. For our monosplit unit, for example, we could reduce the size by 21%. For the multi-split system OneDrive 3, we could reduce the size by 36%. That's more than a third. And for the multi-split OneDrive 6, we could go down by 22% and go from a 2-fan outer unit to a 1-fan type. And of course, as you might know, we have the most complete range of split AC. So just quickly run you through it. For the monosplit AC, we have a capacity range from 5K BTU up to 60K BTU. And all units have at least the A+ energy efficiency class. And up to 24K BTU, we even have the best energy efficiency class in Europe, that's A+++. For our multi-split range, we go all the way from 14K, that's a OneDrive 2 system, up to a 55K, that's a OneDrive 6 system. And also here we have at least A++ or better. So you could already see that with our split systems, we were able to save space. That means less material, easier installation, and less cost for the end user. But now, let's look at the water side of things. What can we do better when it comes to domestic hot water preparation? So here, for our heat pump water heater, we had one task. We wanted to use the R290 natural refrigerant. But at the same time, we wanted to achieve the A+ energy efficiency class, which is actually currently the best achievable for this product type. And this is not an easy task, because in Europe, the R290 refrigerant charge is limited to 150 grams. So what could we do? We could introduce our innovative microchannel technology. So compared to the traditional tubes, we could increase the heating efficiency by 15%. But that was not enough. In order to improve further the heating efficiency, this unit uses a smart heating technology. That means the unit will learn from end user patterns how they prepare the hot water. And therefore, it will go up with the heating capacity when there's a high demand, and it will go down with the heating capacity when there's a low demand. And by applying these technologies, we were finally able to offer the full range